Hi there, Andrew Dunkley here, and this is Space Nuts, a Q&A edition. Thanks for joining us. Coming up, we're going to, talk about something never before spoken of on Space Nuts, a black hole. A little bit of a different twist on this one, though. We're also going to look at the dimension of time, our obsession with life, the Milankovitch cycles of Mars, and Paddy's got an idea for me to write a book. That's all coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And with all the answers is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. It's not all the answers, but, well, 2 or 3 of them.
That's all we need. I thought I'd show you my background today.
Yes, I was going to ask you about that.
All these rockets launching into space. That's from the Sphere in Las Vegas. I took that photo when we went to a show there called Postcard from Earth. And the basis of the story is that Earth's become uninhabitable due to global warming. So everyone basically went, let's get out of Dodge. And that's the scene of all the rockets taking off as humanity leaves the planet. And the whole storyline basically is about people coming back to visit, but we can't live here anymore because we messed it up so bad. And so that's the launch sequence from all the humans leaving the planet after we decimated it with global warming and climate change. And it's a 360-degree sphere in Las Vegas, which you can walk around, and it has pictures on the outside, but on the inside, it's a visual screen that goes all around you. Not only is it showing you pictures, but you can also experience weather while you're there. So you fly over snowfields and you can feel the cold and the wind. You fly over an orchard in California and you can smell the citrus. It's really brilliant, really an amazing facility that they've built there, and all centered around science. So, loved it. Absolutely loved it. Notwithstanding the fact the Eagles are performing there pretty much as I speak. So they do all kind of thing as well. Yeah. But yeah, I like that. I like that as a backdrop. It sort of fits in with what we do, Space Nuts, launching rockets, that kind of thing.
So the reason why Earth is uninhabitable is because of all these rockets leaving behind their trail of
nasty stuff they dumped in
chemicals.
Yeah. It probably didn't help that many take off.
I don't think it would, no.
Let's get down to some questions. And our first one comes from Mark Painter. This one came via Facebook. Dear Andrew and Professor Fred, I have a few questions that puzzle me. Today, I'll start with, of course, black holes. In the movie Interstellar, as they get closer to the black hole, time slows down relative to the outside observer. By extension, as we get close to the event horizon, time would stretch more and more, and I assume follows an exponential curve to the point where time effectively stops. So then, to enter the black hole, wouldn't time have to go in reverse? Could it be that all black holes are actually chunks that come from the Big Bang that did not form normal matter? Thanks in advance. We kind of talked about that in our last episode, the primordial black holes, and they're maybe being responsible for dark matter, which Fred debunked pretty heavily. Yeah, there's a big upcut, really. No, but so he's asking about time being reversed if you entered a black hole. I know something that would be reversed, your life, but that's besides the point.
Yeah, just to elaborate on what you were just saying, though, Andrew. Primordial black holes may exist. We just don't know. And my comment was that I didn't think they would amount to forming the dark matter that we are still looking for. But we do know that some black holes are actually formed from supernova explosions, the debris left over by a supernova, the collapse of the core of a star that has sufficient mass, up to 22, something like 22 solar masses. So the answer to the last bit of Mark's question there. Could it be that all the black holes are actually chunks that came from the Big Bang that did not form normal matter? And some of them probably did, the primordial ones, but some also didn't. We know that that black holes are formed by stars getting to the ends of their lives. And regarding time reversal, Mark is absolutely right that as you, to an outside observer, the closer you get to the event horizon, the more your time to the outside observer slows down, if I can put it that way. And when you cross the event horizon, basically time stops. So your person would be frozen on the event horizon. Although they've actually fallen into it, they don't see the event horizon because that's basically an optical illusion. It's the point at which light cannot escape.
We talked about this some episodes back about how if you were to cross the threshold, black hole, space and time would flip.
Yes, that's right. They do. That's as you get close to it. It's exactly right. The dimensions flip, and we had quite a nice explanation as to why that would be. Which was a
great YouTube video on it, I think.
Yes, that was it. There was a YouTube video, very nicely put. Why effectively space and time flip. And that, in a way, sort of illuminates Mark's question as well. The time doesn't reverse for you. Time basically disappears along with you when you get swallowed into the black hole from your perspective. And it's no good thinking about whether to an outside observer time might reverse, because the outside observer can't see you because by that time you're inside the event horizon, so nobody's going to see you. Yeah. Nobody will feel your pain.
No, but you'll be covered in spaghetti sauce.
Spaghetti, yes, that's right.
In the movie Interstellar, of course, he's referring to a situation where an astronaut did cross the plane into a black hole to help solve a puzzle that they could only solve if they could get inside a black hole.
Yes, that's right. Yep.
Yeah.
I did see the movie, but I don't remember the exact plot. I just remember thinking, no, that couldn't possibly happen. No, what are they talking about?
Solve a gravity problem, and they couldn't do it of a black hole. So that's I had to go in. Brilliant film, but that was probably where it jumped the shark, so to speak, in terms of reality. But who cares? It's science fiction. I loved it. Absolutely loved it. Thank you, Mark. Great to hear from you, and thanks for reaching out on Facebook. Our next question comes from Craig.
Hi, professors. It's Craig calling from sunny Murrumbula in New South Wales. I have a question about dimensions. 1 dimension, 2, 3. They all need time, and we describe time as a dimension, but is it really? It's kind of like half a dimension. We can move in one vector, but not in the other, unless you can move faster than the speed of light. And I don't think we can. So it's not really a full dimension. It's, as I said, more like a half a dimension. What are your thoughts?
Okay, Craig, thank you. Yes, half a dimension. We do describe time as a dimension. And while you're talking, I'm going to do some research because I remember us talking not so long ago about a paper that was released suggesting time travels in 2 directions at once. Was that right?
Yeah, that was for it's the way some quantum processes experience it. I think that was what it was about.
Yeah.
So time is a dimension. This emerged from sort of mathematical studies in the wake of Einstein's special theory of relativity. And so you can write down an equation, if I remember it rightly. So imagine yourself moving in 3 dimensions, a distance which we'll call S. You've got 3 coordinates, And actually, in 3 dimensions, you can write down an equation, which we call the metric, and this is for normal, non-relativistic space, which would be the s squared equals x squared plus y squared plus z squared. That would be a formal equation of how you would move in a 3-dimensional coordinate system. We express these things mathematically. It's called a metric. That is the bottom line of this. But with relativity coming along, people realize that, yes, time behaves just like a dimension. And it is variable. It can be squashed and it can be extended, just as we've been talking about time dilation. Your time can look differently from the time of somebody else who's in a different frame of reference from you, whether gravitationally or moving. So time is bendy. You find that when you, when you move to that relativistic situation, you can write the equation down where you've got 4 dimensions, and one of them's time. And if I remember rightly, it's s squared equals x squared plus y squared plus z squared minus c squared t squared, where t is time. So it behaves just like a dimension. And that is why we call it a dimension, because it is. But it is clearly different in some ways from the 3 dimensions of space, because exactly as Craig says, we can move willy-nilly about the 3 dimensions of space, within reason, of course, but we can move around them. But we can't move willy-nilly around the dimension of time, except under certain circumstances where you're traveling at very high velocities and things of that sort. Mm-hmm. So it is a very unusual, it's an unusual dimension, but it is a dimension. I quite like the idea of it being half a dimension, but I think my mathematical friends would say, no, it's definitely not half a dimension.
Yes, I found several articles on what we'd spoken about,
yes,
which was a paper published late February, early March. In the quantum realm, time arrow might fly in 2 directions. Mark might want to... Craig, might want to look that up and read a bit more about it. But it's a special circumstance, I suppose, would be the best way to describe it. But yeah, it's an interesting article.
And it's an interesting question from Craig too.
Yes, very interesting. Thank you, Craig. Great to hear from you. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson. Let's take a break from the show to tell you about our sponsor, NordVPN. Now, if you've ever felt like your online privacy is slipping through the cracks, then you're not alone. Hackers, scammers, harvesters, they're all out there trying to get your private info, whether that's your passwords or your personal details to sell on the dark web or to use themselves to access your bank accounts, credit card details, and who knows what else. But you can protect yourself with NordVPN. You can take control at home or more importantly, when you're out in public using free Wi-Fi. Right now, using the exclusive Space Nuts offer, you can secure a 2-year plan and receive 4 extra months for free on a NordVPN.com plan. That's over 2 years of top-tier online protection. NordVPN encrypts your internet connection, hides your IP address, and offers access to over 7,700 servers around the world. Plus, with features like Threat Protection Pro, MeshNet, ultra-fast speeds via NordLinks, your digital life stays private and efficient. So don't miss out. Visit nordvpn.com/spacenuts and enter the code SpaceNuts to claim this deal. Remember, there's a 30-day money-back guarantee, so it's risk-free to try. Stay safe, stay private, and browse with confidence. That's nordvpn.com/spacenuts and use the code word SpaceNuts. nordvpn.com/spacenuts. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Okay, Fred, we've got another audio question from a regular sender-innerer. Here's Mikey.
Hey, Fred and Andrew. It is Mikey from Illinois once again. I'm sitting here at 5:30 in the morning, as one does, pondering about life in the universe. And I was just wondering why we're so fixated on life had already happening on other planets. We look for signs of life from the past on Mars, eventually on Venus and all these places that we go. But what are the odds that these places, say Venus, for example, are on their infancy stage of life, and Venus will eventually cool down one day, and when the Earth is long gone, possibly because we've self-annihilated ourselves, maybe one day, millions of years in the future, Venus will be an oasis. I'm just curious on your guys' thoughts of this, and I mean, what are the chances that maybe some planet or somebody in our solar system, as of right now, may not be able to harbor life, but someday in the future will be? Thanks, guys.
Thank you, Mikey. That's a really interesting question. In terms of the Venus theory, you might argue that Venus has already been there, because I remember a story way back when we talked about the potential for 3 planets in our own solar system that all could have potentially harbored life. We know of one, we live on it, but Mars and Venus were also cited as planets that at some stage had what would have been a chemistry, an environment that could have harbored life. And, Mars lost its atmosphere, which sort of put them to bed. Venus went, rogue, greenhouse effect, and that put their potential for life to bed. But doesn't write off the possibility that they might have had it.
That's true. And I think that's absolutely right. Both those planets might have had it. As you say, Venus became, it had the runaway greenhouse effect, which put its surface temperature up to, 450 or thereabouts?
That's,
Celsius. So I think with Venus, it's done its dash, because as time goes on, the likelihood is that Venus will get even more inhospitable to life as the sun basically swells towards the end of its lifetime. And I'm talking now about 3 billion years or so in the future, it'll start swelling. Venus will get even hotter than it is now. Earth might very well become uninhabitable by then. Mars, however, might turn into a warm world. It's doubtful it would regain its atmosphere. It might regain a lot of water, which probably would evaporate into space without pressure of an atmosphere. But yeah, it's a possible future habitable world, even if it's not now. We don't know whether any microbes on Mars, but that's why we're being so careful to avoid contaminating them if there are. Perhaps an even more interesting world is Titan, as the Goldilocks zone creeps outwards, as the sun expands in its later years. Titan is going to become a much more desirable place in terms of habitability. It's the only place in the universe that we know of where there are lakes and rivers in equilibrium with its atmosphere. They are liquid natural gas rather than water. But I think it's a big planet. It's bigger than the planet Mercury. It's a big satellite. It's bigger than the planet Mercury. Maybe that's a place where we could find living organisms some way down the track in the future.
Not to mention Europa, Enceladus, Ganymede, Callisto, Triton, all possible.
Iapetus,
yes. The ice moons orbiting the gas giants are all being looked at favorably for potential life with their under ice oceans. So you can't say never. I mean, we haven't found it yet. We haven't found it yet, but they have found the seeds of life in the geysers coming out of one or two of these moons.
Yeah.
Was it Cassini that did that?
Yes, with Enceladus.
Yeah.
Saturn and Enceladus.
No, it's the evidence is starting to build up. I do believe that we will find something in our own solar system in the not too distant future. That's my theory, anyway.
I hope you're right, because I'd like to know.
And in answer to the initial question, why are we so obsessed with life? Because we are living creatures and we want to know if there are any others beyond our planet. I mean, it's a natural thing to consider. And wouldn't it be great if we found it? It would be the probably the biggest discovery in the history of humanity.
Yes, exactly.
Even if it's a flea or krill. I'm still hanging up.
Oh, yeah. Good one.
Yes. There's krill, there's whales.
Yes.
Thanks, Mikey. Good to hear from you. And our next question comes from Fritz, who's put a lot of thought into this one.
Hi, Space Nuts. This is Fritz from Northeast rural Georgia. My question is for planetary scientists and Mars and water on the surface. Why aren't they discussing further the Milankovitch cycles and the influence on Mars having wetter, warmer phases? This is part of the obliquity, the axial tilt, which can range between 10 to 60 degrees over a range of 120,000 years, up to a longer modulation of as much as 1.25 million years. And even at 40%, it could trigger significant ice redistribution or melting. And this could change what's a cold, dry period to a surface of flowing water at times and a wetter period at times. And this happens regularly, and Mars will have a wet and warm period again. So I'm surprised planetary scientists don't discuss this when they talk about the loss of water, but water is there in the permafrost and such, and where did it all go and everything. But it's not discussed how it will return. Thanks a lot, and love the show. Can't wait to hear more.
Thank you, Fritz. You kind of touched on that when you were talking about Mikey's question and how Venus is probably a write-off, but Mars will actually get back to a state of having liquid water. What's the Milankovitch cycle?
It's actually the Milankovitch cycle.
Milankovitch
is yes, the name of the person who put the idea on the map that various periodicities, and they're to do with the eccentricity or non-circularity of an orbit, the incline of the the axis in the orbit, and other parameters like that, that these things vary in cycles. Mars has had, exactly as Fritz says, a really big range in its axial tilt. 10 to 60 degrees is what he quoted, and I think that's about right. We think the reason why that hasn't happened on Earth is because the moon actually stabilizes the Earth's rotation, so the tilt of its axis has remained much, much closer to its present 23.5 degrees. But the answer to Fritz's question is that actually planetary scientists do look at this. And you don't have to look that far to find papers that refer to these Milankovitch cycles in terms of Mars's climate. I found a nice one by some Swiss authors published in 2019. This is called Timescales of the Climate Record in the South Polar Ice Cap of Mars, and it's basically linking the ice layer deposits in the South Polar Ice Cap of Mars, the largest water ice reservoirs on Mars, as they say in the abstract of their paper, and linking them to climate oscillations, the Milankovitch cycles of Mars's orbit. And so that's quite an interesting paper. As I said, I don't know whether I mentioned, published in 2019 in Geophysical Research Letters. And there are other papers too that talk about the climatic effect of these orbital cycles. So it's not something that's being ignored by planetary scientists. I think the view that they've come to, though, is that they're giving you relatively modest changes in climate. The fact that the solar parameters will themselves change over time, as we were discussing in Mikey's question, that means that even without those, you might find that Mars is warming up enough that perhaps we will see a warm, wet planet one day, but we won't be around to see it here on planet Earth because we'll be gone by then.
Yeah. However, as you said, with Mikey's question, that water will probably get.
It depends what the circumstances are. But yeah, check out Mars and Milankovitch cycles, and there's quite a few papers that refer to it.
Very good. Thank you, Fritz. Great question, though. Love those curveballs. That's a ripper. Let's take a little break from the show to tell you about our sponsor, Insta360, and their brand spanking new 360-degree camera, the X5. Now, at the end of this, I'll tell you how you can get a special bonus as a Space Nuts listener, being a free 114 centimeter invisible selfie stick. It's worth around $25 and you can get that if you buy the standard package through Insta360. So what is Insta360? Well, it's a camera, but it's no ordinary camera. This is a beautiful piece of equipment. It is their flagship model, and it can take footage 360 degrees. You don't have to point it at anything. You just start recording and it records everything around you, and then you can sort out what you want later on through their mobile phone app or cell phone app, and it works on Android and Apple. And it works in all sorts of situations. It works in low light. It works underwater. It has outstanding image quality. We're talking 8K 360-degree video. Night shooting, it's just changed the game in terms of night shooting. And as I said, you just need to start recording, and it will just focus on everything around you, and you can figure out what you want to do with that footage later, regardless. And it's AI-powered. It has all these amazing AI-powered tools that just make the job so much easier. On top of that, there are replaceable lenses. These lenses are made of very tough optical glass, and they are much better in terms of drop resistance than your average camera, and waterproofing to 15 metres or 49 feet. And the list goes on. They are fabulous. Also, the built-in wind guard. We don't think about that much, but wind can really mess up your audio, and they use an audio algorithm to get rid of that problem. So that's the product. If you would like to have a look at it, go to the store, store.insta360.com. That's store.insta360.com. And if you are one of the first 30 Space Nuts listeners to sign up for the standard package, you will pick up that 114 centimeter invisible selfie stick worth $24.99 US. So all you have to do is go to store.insta360.com for the Insta360 X5 standard package. That's store.insta360.com. And don't forget the promo code SpaceNuts. That's very important. So there it is. I'm sure you won't be disappointed. This is an amazing piece of equipment, and you'll have many hours of fun, and I'm sure whatever you do with it, whether it's domestic or professional, it will live up to the expectations. So that's store.insta360.com with the promo code SpaceNuts, and we'll have all that information in the show notes. Now, back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
One final thought, and this one comes from Paddy. He said, "Hi, Andrew and Fred. I have a premise for a book for Andrew. Your discussion on Martian water provoked the thought. What if humans on Mars drink unfiltered water and ingest a Martian microbe that merges with human cells like mitochondria did, resulting in whatever you wish to continue the story with?" I hope you like the idea. Cheers from Paddy. I do like the idea. Funny you should bring that up, Paddy, because this is my last show for a few months. Judy and I are going around the world, basically, and we're going to take our time. And Judy said, you know, I don't want you to get bored. Why don't you write a book while you're away? And I was trying to come up with concepts. I was thinking about maybe, you know, a story revolving around Earth building its own Dyson sphere or some kind of megastructure. But now you've given me something else to think about. So might go down that road, although it's kind of been done before. There was a movie many, many years ago about a meteorite that hit Earth, and it had some kind of viral thing in it that was basically killing people. And the whole story centered around a bunch of scientists that were basically in lockdown in some facility in the middle of the desert trying to figure out how to stop it. I can't remember what it was called, but it was a great film, fabulous film. Scared the bejeebies out of me. It was, you know, it wasn't the Blob or anything like that. This was just a microbe, but it had it just was highly volatile and very destructive. And but look, definitely food for thought, Paddy. I'll give it some consideration. And I wonder how I can actually merge that with the Dyson sphere angle.
I'm sure you'll manage it, Andrew. I look forward to hearing about it when you come back in August. I'll probably get a full rundown of what the plot is.
Yes. A few people have contacted me saying, "Oh, when are you in New York?" I might, and things like that. So
cool.
We might be able to track a few people down and have a chat. But look, what I'm going to try and do during the trip is do some monologues back into the show so I can give you updates of what we're doing. So if anyone's interested, if you're not, I'll just stay out of it.
I think that would be great. I think you should do that. It'll be something that Heidi and I can fit into the scheme of things, I hope, and enjoy it very much. So we'll look forward to that.
Might not be every week, but we're going to some really interesting places. So there might be something to talk about. We'll see. It looks like every time we go somewhere, there's a volcano that erupts. So might be able to do that. Yep. We'll see how it goes. But yeah, we've been planning this trip for a long, long time, and we head off next week. So very exciting, very exciting. And that brings us to the end. Thanks to everybody who contributed. Keep the questions coming because Heidi will need them to try and stump Fred, which is very, very hard to do. But yes, just go to our website and send them via the AMA tab. So there's two URLs, spacenuts.io or spacenutspodcast.com, and keep those messages coming in. And Heidi and Fred will tackle them over the next few months. Gosh, it's hard to believe it'll be that long, but I've never been away from home for that long in my life. But it'll be exciting. And thank you as always, Fred. Thank you very much.
As always, a pleasure, Andrew. And have a great trip. We hope everything goes well for you. I look forward to seeing your emails from time to time to find out what's happening. I'd be interested to know whether you'll be homeless when you get back.
It's a distinct possibility. We put a house on the market and just deal with all that when we get home.
Yeah, there you go. No, it's good. It's good stuff. And so have a great time, both you and Judy, and we'll speak again in August.
Indeed. Thank you, Fred. Thanks as always. It's been terrific. And thanks to Hugh in the studio, who couldn't be with us today. He tried to ride a Milankovitch cycle and the chain fell off. And from me, Andrew Dunkley, thanks for your company. See you in a few months. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.